So, hi guys, I'm Parampit Singh, and as you all know, I have been taking MLP sessions this term, and today we will be having our session 17th, and that is of quiz 2 revision session. So today we will be doing the revision for quiz 2, and we will go through the topics which are in the syllabus for quiz 2 and do some PYQs, mock questions, and some extra questions also related to the metrics, mainly metrics for eva evaluation metrics for classification. All right, and so let's start, and I am recording this session and I will upload the recording in my YouTube channel. So this is my YouTube channel and you guys can subscribe to it and turn on the notification. So I'll be sharing the video in my channel only. Right. And I will share the recording link, uh, video link in the in all the groups where I have shared the link. So yes, let's start. So uh, okay, is the VS Code visible? Like the font size? All right. So these were the okay. So first, let me clear to you all. Um, in instructor in live sessions, instructors said the syllabus is for quiz 2 is from week 5 to week 8, but in this course some TA said that the syllabus is from week 1 to week 8. Okay, so there is some kind of a confusion, but as always, the syllabus is covered. The syllabus is from week 1 to week 8, and where they more emphasize on week 5 to week 8. Okay, so we will be going through we will consider I'm considering that only because of course there will be some questions which cover the encoders, the scalars, and the pipeline stuff, which is not in the which is in the week 1 to week 4. So that's why I'll cover all the concepts. All right, so um, from week 1 to week 4, so everybody knows what was the syllabus and all. Then in week 5 we have the regularization, hyperparameter tuning, and cross validation. And in week 6 we have classification, which mainly logistic, regression, and perceptron. Then in week 7 we have naive bias, and they have introduced us with the MNIST data set mainly, and that is just for example. Okay, and then in week 8 we have k nearest neighbors and support vector machine. So that is the overview. Am I missing something in these weeks? If anybody feels like I'm missing something, you can okay, you can let me know, so we will cover that as well. Guys, just one thing, that please be interactive throughout the session, so it will be helpful for you
बू,
all as well.
बूस्टिंग और बैगिंग इसका पार्ट है क्या
No, it
विकेट?
is in week 9. The decision trees,
ओके
random forest, boosting background. It is in week 9.
ओके
So, okay. In cross validation, we have these stuff like shuffle, split, and all. Then in hyperparameter tuning, we have mainly two things: grid search CV, randomized search CV. In classification, these four are all for classification. These four are classification machine learning algorithms, and rest we have these metrics as well: accuracy, precision, recall, F1 score, and all four of them are computed by confusion metrics, which is the main, right? So this is the complete syllabus kind of we have. All right, so should we just go through the PYQs and mocks, and उसमें अगर किसी को कोई confusion होगी, and we will discuss that topic. Is that approach fine? Like,
नो वीक 5 to 8 एटलीस्ट कॉन्सेप्ट एक बार समझा
I
दो आप।
think yes.
बाकी
ओके
बाकी उसके बाद हम PYQ पे चलते
ऑल राइट काफ़ी सारे टॉपिक्स हो जाएंगे लाइक इफ आई गो इन डीप um okay what about like let's like simply check how many of you want like should we cover up the week 5 to week 8 syllabus ones and okay and how many of you want like हम PYQs के through जाएं like while discussing the PYQs we will cover the topics which we have okay
आई थिंक पीवाईक्यू से जाना बेटर अप्रोच होगा, टाइम कम रहेगा इन पे।
hmm like these are kind of अगर हम इनको कवर करेंगे तो बहुत टाइम बीत जाएगा सो लाइक एक एक को थोड़ा सा भी अगर डीप में गए तो so yes like going through the PYQs with the topics is better because last time same thing happened for quiz one so yes okay so
ओके वी कैन स्टार्ट फ्रॉम
all
PYQ।
right and should we do the mock as well how many of you want to
यस
like
यस
do the mock
यस यस मॉक मॉक।
यस यस
all
यस
right
यस
so this is the
लेट्स स्टार्ट
mock
विथ मॉक ओनली, देन बेटर होगा।
all right so, okay, let it load is it clearly visible um, guys is the font size visible
हाँ विजिबल।
okay so okay the first question is Ashok has to train a logistic regression model with gradient descent which of the following solvers so like according to the documentation mainly these two are for like these two solvers are used for like doing the basically to train the logistic regression using gradient descent okay sag and saga like full form is stochastic gradient descent okay I think something like that so these two are the main I don't know why they have marked Newton CG as correct although this approach is different this is not the uh, gradient descent approach this is like another method which is Newton method or normal equation which we say so like these two are the main uh, answers so like it's okay अगर if you are marking the minimum number of correct options that is fine अगर आप एक भी गलत mark कर दोगे then you will get zero so just like be sure of that in MSQ kind of questions then we have like the type of target so
Yeah,
like
Pram, hello.
yes
In the previous question, then only the right answer is Saga and Seg.
yeah okay that is fine so okay let's move forward so the first one like here we can see like we have a array and that is a 2D array like and inside the array we have like another array that is kind of containing two elements so it is like this okay the first column okay the first element of both of these arrays representing a separate label and the second is representing a separate label okay so we have two labels so that is why it is like multi-label indicator then the second one okay why it is not continuous like and why I have marked as multi-class this the type of target for this one anybody knows
Can I explain the type of target thing
yes
once?
yes yes
I
of
don't know.
course uh, okay type of target mainly like it takes the data and it checks it takes the data and checks like what type of target label, what type of target data we have, whether it is like mainly for the classification. It is under multi-class, so it is for the classification stuff only, whether it is of binary, multi-class, or multi-label. Okay, for the multi-label, the full name is multi-label indicator, right? So that just keep that in mind. Okay. Okay, so about this, is it continuous or multi-class? Like it has some point zero, right? Anybody? Um, okay,
Continues.
okay, continuous.
Multi-class.
Okay, let me open the meeting.
One,
Sorry.
It is multi-class like 1, 2, 3.
Hold- Um, okay. Sorry. Guys, sorry for the that thing. Actually, मैंने गलती से meet का page reload कर दिया. Okay. Is the screen visible? I hope it is
Yes.
visible. Yeah. So it is like it is not continuous. I'll tell you why. Because if we see like here we have the numbers in decimal, but like after the decimal it is zero. Okay. अगर decimal के बाद कुछ भी zero, like apart from zero, if we had any other value like 0.1, 0.1, 0.23, something like that, then वो continuous होता. All right. So we can easily distinct separate these values, right? These are discrete, these are not continuous values. Like 1.0 is same as 1, and this is for 0, this is for 3, so it is multi-class. All right. And this one is binary, it
sorry,
is clear. uh,
sorry,
yes.
Param. How we conclude that this is multi-class?
Because like these values are first of all countable. These are discrete, like 1.0, 0.0, 3.0, that is written intentionally. Like zero point 0 has no decimal value, right? 1.0 is same as 1, we can say, right? So that's why, and these are discrete values, we can easily count them. If there were any value in this array, like let's say 0.5 or something, if like after the decimal we have any kind of number except 0, then वो continuous हो जाता. All right. So that's why it is not continuous and it is multi-class.
Excuse me, Pram, if it is like 1.5,
Hmm.
0.5, 3.5, then it is continuous.
Yes, then it is continuous. Okay.
And if it
And
is
how
like
is it?
1, 2, 3, simple 1, 2, 3,
then it is multi-class.
How is it multi-level indicator?
The first one is multi-level
Yes, yes.
indicator. That is like because we have it is a we have a 2D array here. The first element in both the arrays are for the first label, and the second element in both the arrays is for second label. Okay, so we have two target labels, you can say. Okay, so this is multi-label, multi-class classification,
How
you
do we
can say.
know that they are labels? We can also
Mhm.
consider it as a feature and a label.
No, it is mainly the type of target we are considering. The whatever data we passed into this function, it should be under the target. It is like not the feature. Okay.
Okay, okay. That means we never pass the features, only the labels.
Yes, yes.
Okay.
Okay, so then it is asking, Brajesh wrote the following code. So it is a simple perceptron, and um, okay, he calls the fit method. The parameter learned from previous training session are lost. Okay, So basically, like it he wants to like keep all the training, keep all the weights, whichever the model is learning, like after each iteration. Okay, so what you can do is we can simply set worm start equals to true. I think here to this is from the week 4 only. This we had earlier as well. Like with worm start, whenever we call the fit method, it do a single iteration and we can evaluate, check the weights and the bias for the like model. All right, so this was simple. Then the okay, fourth one. Which of the following variants of gradient descent can be implemented with SJD classifier? Okay, by default, SJD classifier do the stochastic gradient descent only. Okay, um, there is like a kind of batch size or something like that parameter. But that like that doesn't kind of specify कि हम बाकी तीनों भी कर सकते हैं, because there are some different like you can say छोटी छोटी differences हैं if we have to implement like the gradient descent in some batches way, like either it is mini batch or full batch. Mainly stochastic gradient descent is the correct answer, and I think it is given in the documentation as well. Like okay, I have written it well. All right, so यहीं पे okay. So it is written like the class SJD classifier implements a plain stochastic gradient descent. All right. So that we can confirm via documentation. So it's like कोई confusion नहीं है. Just mark this one as the correct. Okay. So that's it. Then the precision recall curve. Plots a graph with the precision value on x-axis, recall value on y-axis. Okay, because the name is precision recall, so you can understand the precision is on y-axis, and then the recall on y. Precision on x-axis, recall is on y-axis. Then compute, yeah, precision recall curve. What it do is like on different probabilities. What like in the classification mainly we get the probabilities, right? So on different probability thresholds, like whether it's 0.5, 0.4, 0.6, on various thresholds, it calculates pairs of the values in pairs, like for precision and recall, and plot the graph accordingly so that we can get a perfect threshold according to the data. Okay, based upon the best value for precision and recall. So that is the simple, like if you ever kind of अगर आप एक भी बारी इसको प्लॉट करोगे ना प्रिसीजन रिकॉल कर्व को in general, then you will get the like you will get the understanding ki how it is working and what it is doing. Then consider a
And
classification.
hello, excuse me. In the
Yes.
second option, compute precision recall pair.
Mm-hmm.
Can you describe some more about
Okay,
the second?
so in
Some
yes, in classification mainly we get the probabilities, right? After the probabilities we have some threshold, let's say 0.5, because probability ranges from 0 to 1. So 0.5, let's suppose the threshold is, and based on that, if like the probability for some value is less than 0.5, so let's say we are considering that sample as like that sample is for 0 class 0 or label 0. Okay, uh, and if the value is greater than 0.5, then we are considering it as like 1. Okay, not 0. So that is how we are kind of separating the values based upon some certain probability threshold. And the same thing, like we can check which probability threshold, what value of threshold is giving us the best precision and recall. Okay, that we can identify by precision recall curve. So we plot the uh, precision recall values based upon different probability threshold. So like we pass on some probability threshold value, let's say 0.2 to 0.56 isn't precision on y-axis. Okay, by default I consider this one. Let me check precision recall code. Just give me. Okay, so all right. So precision is on y-axis and recall is on x-axis. Okay, so okay, that is the correct answer, correct option. Okay, all right. Then in question 6, they are asking like a classification data set with 98 negative samples, 2% positive samples. Which of the metric is more effective? Like, okay, why I have not marked accuracy, or like why accuracy is not being considered if we have imbalanced data set? Like, anybody knows the reason? Um, okay. All right. So is this much like this is clear like why we are not taking the accuracy and why we are taking other metrics like precision recall and F1 score. Guys, if it is clear, you can give a thumbs up so we can move on. If not, I can explain.
Can you tell once why accuracy is not helpful?
Okay. So let's suppose a basic thing. Let's say you have trained a model and you are getting the same accuracy like as per the date, like as per the classification, okay, as per the ratio, the distribution of the target label, that is like you are getting the accuracy of 98%. Okay, so
Okay.
just by looking at the accuracy you will feel ki your model is very well trained because you are getting 98% accuracy, but it is just like it is just that it is classifying only the zero or the like negative samples correctly, and rest of the positive samples which are only 2%, it is misclassifying them, your model. Okay, so that we cannot capture that, we cannot capture that is it classifying both the different values, like both the negative samples as well as positive samples, like in same distribution or same ratio. We cannot like identify that using accuracy only. Okay, so that's why accuracy is not being considered as a like good evaluation metric when we have a imbalanced data set. If the data is almost balanced, let's say 60 to 40 or 50 to 50 something, that kind of ratio, then using accuracy is like okay, for the base metric you can consider accuracy, but if we have like if you have other options like precision and recall, go with them. And the F1 score is kind of the combination of precision and recall. It is the harmonic mean, basically, like it divides the sum of precision recall. Okay, it multiplies the precision and recall and divide them by their sum. Okay, um here it is given large negative values. Yes, like mainly like we consider the F1 score. Regarding the precision is opted when we have more positive values. Um, okay, uh, more positive values. Like okay, mainly तो like in F1 score we get a combination, and अगर हमारे पास F1 score option होता so we mark that only. If it was MCQ then we consider that only. अब like यहाँ पे recall would be the better. Okay, अगर precision and recall में choice हो, why? Because we have only 2% positive samples, and in recall, like a recall is mainly used when you have kind of some data set with some rare kind of problem. Like let's say we can assume like only 2% are positive samples, and that we have to mainly classify. So recall is much better, and precision is not good, but like F1 score is there, so it is an MSQ. So I have just marked based upon that thing ki F1 score uses both precision and recall, and we get a balanced answer, right? So like ev evaluating the model with both precision and recall, that is also better. Like it is same as evaluating with the F1 score. Okay.
Excuse me, Param.
Yes.
Uh, Data is very imbalanced, like 98 and 2.
Mm-hmm.
Then answer should be F1. F1 is harmonic, mean that it
Mm-hmm.
balance both of the
Mm-hmm.
class. Then why it is precision and recall
Like
individually?
okay. Individually, like exactly though we don't know about the data set condition, right? It may be like हमें सिर्फ यही samples we only have to predict, mainly our purpose is to predict only for the negative samples, or maybe our purpose is to predict only for positive samples. Okay, that is also one reason. Like we don't know the purpose exactly, right? If we know, like we have to our more we have to mainly look into the positive samples, then answer would be recall. Okay, not precision. Where but here the problem statement is not described. Okay, so we can take both of them, so it's fine if we consider both of them if you don't know the problem statement exactly. Okay.
Okay, okay. But
Mm-hmm.
uh, uh, F1 is the harmonic mean.
Mm-hmm.
Then if there is no option other than this, then we should mark the F1. If there is no option like recall or precision, right?
Okay, अगर तो MCQ आएगा, if you get a MCQ to mark
Mhm.
any one of the from the following and you don't have the kind of any problem statement overview, just mark the F1 score, that is fine. Okay, if it is MCQ, because F1 score is better, like uh, is more
अगर हमें
used.
खाली एक ही मार्क करना है
एक
वन
ही mark
वन
करना है,
ऑप्शन
that's why I'm saying just mark the F1 score if it is MCQ. Currently we have
ओके
MSQ, so that's why I'm marking three of them, and not the
ओके
accuracy I have explained already.
Hi, Param.
Yes. Um, okay, so now let's move on to the next question, multinomial NB. And okay.
Hi, Param.
Yes.
Uh, just a doubt in the previous question. If the data set was imbalanced, means it is imbalanced, but in opposite way, means
Mm-hmm.
98% positive and 2% negative, then
Mm-hmm.
we have the same answer or something different.
Yes, then we have also the same answer. And like हम हमें मेन पर्पस नहीं पता, like do we have to identify, like हमें ऐसा मॉडल चाहिए कि जो पॉजिटिव सैंपल्स को अच्छे से आइडेंटिफाई करे या सिर्फ नेगेटिव को करे. If we have the kind of problem statement or something like that, then recall would be not the precision, recall. Okay, so then recall would be the better answer. Like अगर हमारे पास ये होता कि जो हमारे पास the positive samples हैं, and we have to like identify the correct
Means
samples based upon the
basically in imbalanced data set, we go for recall.
okay, not exactly recall, it depends upon the problem statement. Mainly we go for F1 score. Okay, if you know the problem statement well, and you know like which one is more important to classify, like the positive ones or the negative ones. If the positive ones are more important, then recall is a better option. If it is like if the negative ones are important, then precision is fine. Okay, so that is the main thing which like I follows mainly, like whenever we I train a machine learning model or 2 ML. Okay, and okay, now let's move on to the next one. So we have a multinomial NB that this is the naive Bayes ML algorithm, and multinomial means we have like um it is okay. Multinomial, like multiple values, mainly multi-class, we can say. Okay, so multinomial is best suited when next feature contains text data, not the word count. Okay, we need the counts, we need the data in numbers, obviously. So that is not the correct option. Contains word count for text data. Okay, so this is the correct and suitable for classification with continuous feature. No, for the continuous features, we had I think the complement NB. If I'm wrong, I think I'm wrong. Or maybe some other. There were four uh, like naive bias implementations, right? I think. Okay, I'm just a little bit confused in that, but the answer for this one is the second one, like when we have the word count for the text data. Okay, obviously we need the training data in numbers, right? So that this is okay. Now the question 8, we have a multi-class classification problem with n classes. Which of the following method requires exactly n classifier? Okay, so this is kind of, you can say, deep or the extra topics mainly. Um, so one versus rest classifier is kind of like it is taking the one class, like let's suppose you have 10 classes from 1 to 10, and one versus rest classifier do something kind of like um, let's say we our main goal is to predict for the value 1 in the target label, so it considered the 1 as the main label, and for rest of the label it considered them as equal. Let's say like we mark them as 0 or -1, and we mark the label 1 as the 1 only. So that is what 1 versus rest 2, and then 1 versus 1, like for each it simply create each combination, and it do like okay, so if we have n classes, then like 1 versus rest would be better, because for each class, like it will we have a classifier, and like let's say we have, okay, I'll simply take an example. Let's say we have three classes to predict, 1 2 3. Okay, then we will have three of these classifiers. Okay, we need exactly n classifiers. So for three classifiers, then for that 1 versus rest would be better, because like let's say the labels are 1 2 and 3, then for the label 1 we have uh, like one instance of this, then for the label 2 we have another instance, then for the third label we have the another instance. Okay, why not 1 versus 1? Because then we will have for each of the combination, like for the 1 versus 2, 1 versus 3, and similarly for the 2 versus 3, and mainly okay, 1 versus 2, 1 versus 3, and then 2 versus 3 as well. So we will have like various combinations. So, and that is like not the exactly we want only exactly only n classifier. So 1 versus rest would be the best approach. It is like mainly you are counting okay, permutations of for the unique values you have in the data. Okay, then which of the following options are correct regarding regularization? Regularization is used to avoid overfitting by obviously by adjusting the loss function, like how much you have to uh, decrease in each value, not how much we like we mainly minimize the weights. Okay, so kind of we are helping the okay, where to use 1 versus rest and 1 versus 1. There is not exactly like any kind of okay, for binary classification you can go with 1 versus 1. For multi-class classification you can go with the 1 versus rest. Okay, for binary classification as well we can go with 1 versus rest, that is fine, but if you have multi-class labels, then 1 versus rest is best. Okay, it is more appropriate, because then we have a good amount of like classifiers, you can say, rather than 1 versus 1. Okay, uh correct regarding regularization. So obviously regularization avoids overfitting, and mainly like if you see the like changes in the model when you use regularization, it mainly do the changes in loss function. Okay, it adds some one more parameter like which we call alpha in the scikit-learn. Okay, that is to keep to maintain the value for like how much we want the weights to be minimized. Okay, so it is basically we are adjusting the loss function itself because we plot the graph of for the loss function only. It increase the bias and variance. No, that it doesn't. In fact, it decrease the bias. uh, then elastic net regularization is combination of L1 and L2. Yes, that is correct. That is, I guess, from week 4 we know. Okay, it controls the number of passes. No, that obviously it is not the correct answer. So it is like basically they are asking for what regularization do. Then the
In this question, when it decrease overdraft overfitting, then it is decrease the variance
um yes,
and
when we
increase
are
the bias.
right, increase the okay, not exactly increase the bias,
Okay, but decrease the
decrease,
variance, right?
yes, obviously. If we
If
have the
there is the
overfitting, then it
option,
means we have like our model has more variance. All right, so count vectorizer. Okay, so basically it takes the uh, samples. Okay, so we have a list and we have this only one sample, and it is basically it will count, it will separate them, okay, word by word using the space, and then it will count the occurrence and give us the final, okay, array, x dot 2 array. So why we are getting like 1 2 1, why not 2 1 1? um,
alphabetically.
Alphabetically.
yes,
Okay.
alphabetically. Okay, so it is considering lowercase as like small kind of, you can say, it is giving more priority to the lowercase alphabets than the uppercase one. All right.
Param, sorry, I didn't understand this. Can you please re-explain?
Sorry, can you repeat once?
Can you re-explain this calculation from the beginning?
All right, so count vectorizer, what it do is it takes like uh, some data, especially in text, and it separates the text in like words into words. Okay, by separate using basically calling the split function on the data. Okay, then we have each separate word, and it basically counts the frequency of each word in the data and gives us the mapping, or you can say like not exactly the mapping, the count of each of the word. Okay, and obviously it gives us the sorted mapping based upon the data we have, like it considered the lowercase alphabets. uh, Basically it gives more priority to lowercase alphabets than the uppercase ones. Okay, so that is why like we are getting the accuracy of grade like before.
Will it sort on the basis of alphabets, like V comes before H, V first it is, you can say V,
G comes
then
before,
H.
that you can say, of course, but like it is in lowercase as well, so we can consider that as well. Doesn't it convert?
No, if hello has H as in lower case, so what
Yeah.
will be the new
Okay, let me check once. Count. Scalar. Um, it will convert your text to, okay, it is converting the text to lowercase, and yes, alphabetically. Yes, obviously alphabetically also G comes before H. So yes, that's why it is mainly sorting the data set. Okay, so
So,
by
it doesn't differentiate between lowercase and uppercase. It converts everything into then the
okay, if we have like same words but in different case values, uh, like let's say one hello in lowercase, one in uppercase, but it just mainly consider both of them as equal. Okay, it
okay, got it, got it.
yes, it converts the data into lowercase first, then it do the then it counts the frequency. Okay, and that frequency it gives us in the sorted manner, sorted based upon the uh, alphabetically sorted manner. Okay, then we have this question.
Param, I
Yes,
want, if there was one more line in the previous question, like this is hello, this is word, one more line, then it one more array create, or it is only one array?
it will give only one array, not
If
multiple.
one more line written,
See, यहाँ
like
पे
this
we
is a
have
day.
only one. We can
If
say
we
we
have two
only have.
lines,
Yes, if we have two lines, then also we will get the same answer, like only in the 1D array itself. Okay, and for each, basically we are getting the word mapping from the whole data. Okay, like
I
the
mean,
frequency of the words from the whole data.
okay.
Okay. Then from the above code, what pipe? Okay, pipe one fit transform do. Okay, so pipe of, like, we are passing a index 1. Okay, so imputer is on index 0, like in the steps, and then scalar is in index 1, then model is in index 2. Okay, so pipe of 1 fit transform means we are mainly scaling the data using min max scalar. So apply min max scaling on the x. Okay, so it's this is the simple thing. And okay, then the mean absolute error. So we just have to compute the mean absolute error for this data. Mean absolute error is taking the absolute values. Okay, taking the difference first, then like making them positive by finding their absolute value. Okay, and then simply you just have to sum all the absolute values and divide it by the number of samples which we have. Okay, so like 3 minus 2.5, here we get the 0.5 for the first one, then again we get the 0.4 for the second one, then here for 0, and we'll get the 1 here. So 0.5, 0.5 and 1, the sum will be 2, and we have 4 samples, so 2 divided by 4, 0.5. Okay, that is yes.
Right, right. Okay.
Why is it
Continue.
Okay,
why is it so easy?
sorry.
Okay,
Param, Jeet, your voice is not clear.
My voice is clear.
No, no, Jeet. I think Jeet Kumar voice.
Yes.
no, we can move on.
All right.
Okay.
So then we have the precision score. Okay, y true, y right. And one more thing, by default we have the value as weighted, right? So it by default computes the weighted precision score. Okay, that I'll explain you in a little bit when we go into the confusion matrix. Difference in macro, micro, and the weighted parameters which we have. Okay, so we get a slightly different answers when we set those parameters. Okay, so this is some, just simply we are calculating the weighted precision score, you can say.
What is the formula?
Okay, formula for
How
precision
to
is
find this one?
okay.
You will take in the last, or it's over?
Okay, the formula, basically formula is the true positives divided by true positives plus false positive. So it is basically, formula is like jitne, out of all the positive predictions which we have done, how many are actually positive. Okay, so that is the formula for precision.
Yeah,
Out.
but Okay, so we have to consider one as positive and zero as negative.
Yes, by default we consider 1 as the positive and 0 as negative. Okay, or we can specify
Okay.
also, like in these metrics, which one should we consider positive or negative. Okay, then we have about KNN model with low values produces complex and smooth. Yes, that is like
Sorry.
if you have yes, um yes, Chief.
In Y thread, both of them are included, like false positive and true
Sorry,
positive.
your voice is not clear.
I'm saying in Y pred, the false positive and the true positive both are included.
um in Viprad we have all the values, right? Some are false positive, some are true positive, some are true negative, some are false negatives. We have all the, like we have all the combinations using Ytrue and
So,
Ypred. We first have to create a confusion matrix of it. Okay, the simple thing approach to, okay, to approach this kind of problem, first create a confusion matrix using these labels. Okay, then find the, then you, by using the respective formula, find the value. Okay.
बट परम ही ना एग्जाम में हम कंफ्यूजन में क्लिक
okay,
करने में, एग्जाम में तो मैनुअली करना पड़ेगा ना,
Yes, but that is easy,
तो
that is not difficult, like we
कैसे
have
करेंगे वो नहीं समझ में आ रहा, थोड़ा एक्सप्लेन
uh,
कर दूंगा.
okay, all right, first let's cover these four questions,
ओके ओके
then
ओके.
I will do the that confusion matrix one exactly. Okay, KNN with low values of k, yes, that is correct. Like if you have a lot of data for classification, and if you see, like simply plot the data using the decision boundaries which you get, which we get, then if you have some low values of k, then thoda sa uh, like with low values of k, our model tends to overfit, like it tends to classify all the samples correctly. Okay, so we get some kind of complex decision boundaries, like very curved decision boundaries, you can say, for each of the values. If we have like higher values of k, then we get some different decision boundaries for them as well, so hence like smooth decision boundaries. Okay, I'll give you the example for this. Okay guys, just a second, let me add the pen tablet once. Just a second. uh, Not here. Later. Okay, so I'll be keeping it here on. Um, all right. Regarding, okay, first let's get clear with the KNN one. Let's say you have the KNN. Okay, let me. You have k equals to 2. Okay, in KNN, and our data looks like something like this. If I plot it, um, like we have two features kind of, and we have two classes as well. Okay, so let's say these are some samples which you can say we have, and like basically a binary classification problem you can consider. Okay, So if we have k equals to 2 means like two separate basically uh, one decision boundary we will get, right? And let me make the decision boundary using green. uh, Only black one, that is fine, I think. Okay, so if you see, like, some blue samples are here as well, right, with which are kind of very much in the area of red samples. Okay, so if we have low value of k, then what we will get is we will get some decision boundary, some kind of like this. Okay, this kind of decision boundary. So this is very much you can say the case of overfitting, because like uh, on the based upon the decision boundary you can check, right, like it is trying to classify all the samples correctly. Okay, so that's why we have a very complex decision boundary as well. Okay, and in the others, on the other hand, if we like, okay, let me select this one, and if I plot it here once again, let me erase them first. Okay, if we have some k value, some higher k value, let's say k equals to 4. Okay, so first one to decision boundary we will get something like this, you can say something like that. Okay, a very smooth decision boundary. Then another decision boundary you can make something like that, and some another decision boundary you can make something like this. Okay, so we will get various decision boundary, of course, with the more the k value we have, and more number of decision boundaries we will have, but that will be very smooth. Like, let's say k equals to 5, not 4. Okay, so we will cover all the various samples, all the rest of the samples as well. So for this also we will get some kind of this decision boundary. All right, not like the previous one. Okay, I have just covered them up. So not like the previous one. If you see, like, if you compare both of the lines, the right one has a very smooth decision boundary, right? We have more number of decision boundary, but we have very smooth decision boundaries, and hence our model does not like tends to overfit. It tends to generalize the data. All right, so that's why it is being considered to have like some good value of k, basically like some higher value of k, so that would be more suitable. All right, I'll go with the confusion matrix also, just like we'll cover these two questions first. uh, Feature scaling does not impact, yes, feature scaling does not impact the knn. Doesn't matter, like we have the data. Okay, we have the data something like this, or if we in fact do the scaling, then also we will get the same data, like, but in a scaled manner only. Like, if I, okay, for the scaled manner you can consider something like that. Okay, so this is kind of a scaled version of the above one data set. Okay, then also we will have the same decision boundaries. So the main thing is the k value and the metrics which we use. By then the next question is, by using all features of the dataset, accuracy score is 100 accuracy score is achieved on the training set, but on the test set we are getting accuracy as 70%. So that is obviously our model is overfitting. Like, we are getting more accuracy on training dataset compared to the test dataset. Like, mainly, like, we should get good accuracy in our test data set. Okay, so that is like, if we are getting a almost same accuracy in test and training, then we can say our model is perfect. Okay, if we are getting very low accuracy in training and test, then our model is underfitting. Then larger, okay, then about the regularization parameter c in svc, larger value of c will obviously overfit the training data set, and smaller value will underfit the training data set. Like, the margins which we get, that uh, we are talking about like the difference in the margins. Okay. Then in the SVC, what kind of like how many kernels, what different values of kernels we can have. The poly, RBF and the linear also we have. Scale, we don't have any kind of these two kernels. So it is basically the documentation. We have to read the documentation. That is not like a good approach, but that is fine. Okay. So okay. One thing. Yeah. Regarding this, like when to check your model is overfitting or underfitting, what you can do is like a simple, I'm sharing like a simple insights. So, okay, I'm denoting the trainings. Okay, let's consider the accuracy only. Okay, the TS basically representing the training score. Then the VS basically represent the validation score, and then let me remove the accuracy from here. Then we have another test score. Okay, so test score something like that. So concept of underfitting, overfitting, and generalizing, like model is generalizing. So there are like three cases in a model. Okay, this is a simple concept which I forgot to cover up in the earlier sessions. It is like uh, how to check our model is underfitting or overfitting or it is generalizing. Let's say training the accuracy. Okay, so we are considering the accuracy only. Let's say the uh, training score is something kind of 30%. Okay, and the validation is also around like that, you can say 25%, and here also 25%. Then our model is underfitting because like our model is not able to learn the data properly, and hence we are getting very low accuracy on the training data itself. Okay, so then our model is underfitting. And then overfitting, if you are getting a very high value on the training set, let's say okay, not 80, in fact let's suppose say 90, and then on the validation set we are getting 85. Okay, that is fine, but then on the test set, let's say 70. Okay, so that is the case of overfitting. And then generalizing is like we have almost same scores, just like 2-3%, the difference is there of 2-3% only. Let's say 90% is here, 87 is here, and kind of you can say 82% is here. It depends on only on training. uh like it depends on both of the data sets. Okay, so okay, it is 90. Let me write it once again. All right, so let's say if we are getting the 90% accuracy on the training set, on validation we are getting the accuracy of, let's suppose, 87%. Then on the test set we are getting accuracy of 82%. Okay, so this we can say if we are having a model something like these metrics, these accuracies. Okay, then you can say your model is perfect. There is no overfitting and underfitting is happening. Okay, if you have very low training set, like training error, then model is underfitting. If you have very high training error, sorry, the accuracy is very high on the training set, but very low on validation or test set, then your model is overfitting. Okay, um, like you can simply like check this and try to basically create some models and evaluate the accuracy on different data sets, then आपको idea लग जाएगा. And the one thing, like here also we have some kind of differences, right? Like we have the 3% difference here, and here we have the 5% difference here. That is like a small difference which we have. That is fine because test data is like completely unknown to us, right? Test data you can consider as that is completely unknown. The validation data set, which is what we is the same data set which we get from the same distribution. Okay, so like uh, if we go in deep, then there are various other things as well, the distribution which we are getting for the different data sets and a lot of things, but generally you can consider this table. Okay, uh, if the training set is accuracy on training data is very low, then model is underfitting. If it is very high and low on test set, then model is overfitting. Just that this is very simple technique to remember whether your model is overfitting or underfitting. Okay, so that is it. Then regarding the confusion metric.
Can you I have just posted your thread from Twitter here.
Mm-hmm.
So maybe I thought it will help everyone.
Okay.
It's very clear.
Yes, I'll share that one as well. I'll just let me clear the confusion metric concept one.
And after that, can you please go back to question number 7 once
Okay,
after you do this? Yeah.
all right. So, okay, so first let's do the confusion metric stuff. So let's say, okay, first I have to create some data. So let's say y and y hat. Okay. Um, so I'm simply like plotting some data points. All right. That is okay. Let me see how many we will get. We have 1 2 3 4 5 6 7 8 9 10. Okay, so that's fine. So we have 10 samples. All right. Okay, so it's very big. So we have m equals 10. That means we have 10 samples. Okay, so this is some kind of a, you can say, your data we have like uh 0, blue is representing 0 and red is representing 1. All right, so that we can say. And then if I create the confusion matrix of it, okay, regarding the confusion matrix, you guys tell me like where do we have the positives and negatives. So let's say 0 1, and okay, let me color them once. Predicted and actual. 1 1, then 0 0. Okay, okay, not that. Let's say this one. Yeah, that would be more better. Okay, so okay, first of all, let's like check the values. So what are true positives? How many true positives we have?
3.
Okay, 1 2 and 3. Right, we have 3 true positives. Then check for the true negatives. Let's check for the true negatives. How many true negatives do we have? Only one, right? The blue ones, where we have the same blue values for y and y hat. Okay. Then what about false positives? Okay. Anybody knows like which data samples are considered as false positives? Okay, answer is four. Someone is saying 4, right? Okay.
I think
So
it's 2.
yes, it is true. Okay, I'll clear that once. Then okay, false. So false positives are like basically the number of samples which are predicted as positive, but they are actually not positive. Okay, they are actually of some other class, let's say the negative. Okay, so that's why false positive. Then false negative, which are predicted as negative, but they are not negative. They
Both.
are actually
In this case,
positive.
it should be 4. False positive should be 4. We are considering red as positive, right?
Yes, red is positive. So y
Y
hat.
is y is predicted, y hat is actual.
No, 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 no. Okay, that is a little confusion. So let me write it here. Y is actual. Okay, y hat is predicted.
Okay.
So generally also we consider the y hat as a predicted value. All right. So this is the we have, and if we sum them up, we get the value 10. Of course, 6 and 4, 10. So that is the total number of samples which we have. Okay, so now to plot, just like match the values. Okay, so let me okay, so there's some little mistake. Let me add the 0 here and 1 here, so we'll get the good confusion matrix like in the same values. So where, okay, uh the first row is representing like all the positive samples, right? The second row is representing all the negative samples, actual negative. And okay, so let me write it something like that. This is the row 1 column 1, row 1 column 2, row 2 column 2, row 2 column 1. Okay, so where do we have the true positives? True positives are those who are actually positives and predicted as positives. Where can we have the true positives? Like in which box?
R1
R1
C1.
C1.
Yes, row 1 C1, which is the true positives, and those are 3. Okay, then for the true negatives, like predicted as negatives and actually also they are negative. In which box we can have the true negatives?
R2C2. True
Yes,
negative.
R2C2, which is like true negatives. Then false positive. False positives are those which are predicted as positive, okay, but they are actually negative. So where can we have them?
R2 C1.
Yes, they are actual. They are predicted as positive, but they are actually negative. So that's why false positives here. Okay. Then the false negative means predicted as negative, but they are actually positives. So the last one, which is here, false negative, which is 2. Okay, not 2, 4. And then again, if we sum up, we'll get the 10 as answer. Okay. So, all right. So is this like clear to you all? How to create a confusion matrix? If anybody has any doubt, you can ask. We have already done few questions in the earlier sessions regarding the confusion matrix. Okay, so just like to keep this in mind, I'll create one more to cover up the, like, to clear the confusion. We get the confusion of like where to have false positive and false negatives, right? So let's say actual is here, predicted is here, and 1 0 0 1, something like that. Okay, so first of all, the true values will be in diagonal generally. Okay, if you don't have the confusion matrix, if you are creating a confusion matrix, create something like this. Okay, I usually create something like that only. So we will get the true positives here and the true negatives here. So true values will be diagonal and the false values are obviously in the opposite diagonal. But which value is where? Like, just check the like we have the false positive and false negative. So okay. Madhusudan, can you turn off your mic? Like regarding this, just check the you can say the these alphabets. Okay, so the positive ones in the true positive, false positives are come under the predicted positive values. Okay, so हम predicted values के base पे we mark these values. So the true positives are for this under the label 1, and hence for the false positives as well. Okay, and for the negatives, the true negatives are here and the false negatives are here. So just like the negatives are 0, so just like use this as a trick to mark the false positives and false negatives. All right, and then you will get the correct confusion metric. So आपको कोई confusion नहीं होगी. so then that will be easy. Okay, now just
Paramjit,
yes,
can you just write the formula for precision and
yes,
recall?
I am going into that only. Now for the accuracy, how do we calculate accuracy? um
True positive plus true negative upon total.
yes, upon total, which is true positive, true negative, false positive, false negative. Okay, so that is the accuracy. Then the precision. Okay, so let me highlight it as well. So accuracy is being computed using this one, like taking these values in the all right, so bit dark हो गया. So taking these, okay, yeah, taking these values in the, these diagonal values in the uh, numerator, and rest the sum of all values in denominator. Okay, so that is how we can compute accuracy. Then for the precision, okay, let me mark it again, say this one. For the precision, see, the precision is basically out of all the positive predictions, how many are actually positive. Okay, go by the definition. Out of all the positive predictions means this column. Okay, out of all the positive predictions, how many are actually positive, which means this one. We will take this one for the numerator. So the formula of precision will be true positives upon true positives plus false positive. Okay, then we will have the recall.
Yeah. With respect to the prediction.
Yes, okay, let me write it once again. The formula of precision is, okay, let me write it here. uh, just like go by the definition is very easy. Out of all positive predictions,
Yeah, prediction. Right.
means जितने भी हमारी positive predictions हुई हैं, that is the first column, right?
Yeah.
How many are actually positive? Okay,
Yeah.
so this that means this true positive, like out of all the positive predictions, how many are actually positive. So this is the recall, this is the precision. Then for the recall, okay, let me take this one. Recall is out of all the positive values, actual positive values, how many are predicted as positives. Okay, how many are predicted correctly, you can say, like out of all the actual positive values. Okay, this one, if I use this too, so this one, how many are actually predicted as, how many predicted correctly. Okay, so this is the recall, which is true positives upon true positives plus false negative, and all true values divided, yes, for the accuracy, all true values divided by all the values. Okay, we can also write it like this: all true values divided by the all values or sum of the values. Okay, so this is the difference in accuracy, precision and recall. So आपको इतना समझ आ गया, like how to calculate precision and recall. Okay, recall is, let me write it, out of all positive, actual positive values, actual positives, okay, or true positives, you can say. Out of all true positives, how many are predicted correctly, how many are predicted correctly. Okay, so in recall we take the actual positive values as base. In precision we take the predicted values as the base, like as the denominator. Here you can see now, this is like these two values are from the predicted label, right? We are taking the predicted value as a base value, which is the denominator. In recall we are taking the actual value as the base value, which is this first row. All right, so this is the difference in precision and recall, and that's why we consider recall like whenever we have small proportion of like some positive samples. Okay, because we have to check like how many of from the actual positive values, how many of them are predicted correctly. So like for the some rare case, if you want to go in more deeper, like I have explained in very deep in the earlier sessions. Okay, okay, let me provide you the session number. um yes, in session 15 I have explained it in like very clearly, when to consider recall, when to consider precision and accuracy and all. Sorry.
No, continue, continue.
Okay. Then we have the last thing, which is F1 score. Okay. F1 score is harmonic mean. Harmonic mean is simply, it is the mean value. Just that in a, like you can say in a different manner. That is like in mean we sum up the values, right? So F1 score is harmonic mean of precision and recall. Okay. We have the base as like precision plus recall. Then in numerator we multiply the precision and recall with 2. Okay. So this is for the F1 score. This is the formula of F1 score. F1 score is kind of you are balancing both of these, precision and recall. Okay. If you want to like measure your model based upon both of the metrics, precision and recall, go with the F1 score. Okay, so that is the, you can say, that is, that will give you the one value mainly rather than checking for both of the values. Okay, so this is all about it. Then uh, I have like a few days ago I have created a cheat sheet and shared it regarding the evaluation metrics. So okay, so here I have this cheat sheet. I have the dark version and the light version, both of them. So this is the cheat sheet which I have created. Here I have shown all the like the steps to create a confusion matrix. Okay, like create an empty matrix, then mark the respective labels. Positive predicted column contains positive labels, means true positive and false positive. Okay, then the negative predicted column contains negative labels, false negative and true negative. Then just fill in the values. So these are the steps, and I have written the like uh, their description as well for each of the value. Like false positives are actual negatives but predicted positives. Okay, then this also like to check for the various metrics, like for the accuracy we take these two values as numerator, then for the precision we take these values. Okay, and for recall we consider these values based upon this kind of confusion matrix which we have. So I have created this cheat sheet both in uh like in light mode and dark mode, so you can prefer to any of them or both of them. I have shared it already in the group, or like Madhusudan has shared the Twitter link, tweet link as well, or you can just go to my GitHub repo, this repo, my resources, and you can download it from here. All right. So आपको ये सारे clear हो जाएंगे अच्छे से if you like want to clear them once again. Okay. So is the like confusion matrix, precision, recall, F1 score is clear to you all? Like, is it clear, or do you guys have any doubt? Okay.
Yes, very clear.
All right.
Like accuracy is our model accuracy, and F1 is the harmonic means
Mm-hmm.
between the
Mm-hmm.
recall and
Yes.
precision.
Yes.
Actually, recall, what is recall? I mean, from what we predict from this,
Okay.
it is also a kind of accuracy of the
Uh,
model.
yes, you can say for only recall is kind of, you can say accuracy, but only for the positive samples. Okay. Recall basically tells ki how well your model is performing for the positive labels. Okay. Like recall, the definition of recall is I have written in the cheat sheet as well. Like
Yeah, definition is also say the same thing, like it is
out
kind
of
of the
all actual positives, how many were predicted true. Okay, That means like how many, like out of all the actual positive values, which means these values, out of all the actual positive values, how many are predicted true, like this one, true positive. It basically helps us to identify like how our model is performing for the positive samples. And that is why, like I say, recall is more preferred when you have a kind of like a very rare positive, very imbalanced data set, and very rare positive values, like 2% only positive values, 2% positive and rest 98% negative values. Then recall would be better, because recall would only calculate for these 2% values only. Okay, so for these 2% values you can check like how many of them are predicting correctly, or
Right.
as like how many of them are predicting correctly, or like uh, how better our model is performing for the positive samples, or only
Yeah.
for the small proportion of the samples.
Small proportion of the
uh, yes,
sample, right?
yes, Shankar.
Okay. Thank you. And
Uh,
the
Param,
Yes.
sorry, Amit, go ahead.
okay. Question from the mock, the we are sticking on the question, the numerical question, numerical one. Which one is given? The we need to find the,
Yes, this
yeah.
one.
So it's over, or we need
It's the
we will
same,
be.
like the we have the y true and y predictions, right? Just plot them like this, like I have plotted in the colors. Just write them exactly in the pen and paper,
Okay.
and simply just calculate the true positive and the other values, and create the confusion matrix. Then you will be easily able to uh, calculate the precision score. Okay.
Okay. Okay.
Yes, Shankar.
Yeah, Parampreet, can you just explain the question number 12 again?
Okay, so first let's go
थोड़ा
with
सा
the,
कंफ्यूजन है उसमें.
okay, question 12. All right, मैं अभी उस पे जाता हूँ. First let's clear the question 7 also. One was asking regarding question 7, right? So okay, in question 7 it is asking like for the multinomial NB. Multinomial NB is like to uh, we create the multinomial NB. Okay, let me go with the skill and documentation. Multinomial NB skill. So multinomial naive Bayes, it is like a kind of a implementation of naive Bayes classifier. Okay, suitable for classification with discrete values. Okay, example word count for text classification. All right, so example भी हमारे पास same ही दिया हुआ है. So multinomial NB is used like to do the uh, classification, mainly for the multi-class classification, you can say. Okay. um and we have other also. Oh yeah, I forgot to like tell you all about this. I have covered this in the previous session. Bernoulli is for like when you have two samples only, like two discrete values. When you have more than two discrete values, we use multinomial. Okay, when we have only two discrete values, let's say 0 and 1, then we use Bernoulli one. If we have the categorical data, we use the categorical NP. And if we have imbalanced data set, we use complement NB. If we have continuous values like the regression problem in the target label, we use the Gaussian NB. Okay, so these are different implementations of the naive Bayes, and some obviously the formula will be different a little bit for all of them. Just that is we can use naive Bayes in different situations accordingly. Okay. Then the last one, the 12th, okay, 12th you were asking, right? Shankar?
Yes, 12.
Okay, so 12th, if I just simply copy this, so we have these values, right? In the 12th one, uh, we just have to simply calculate the mean absolute error. See, obviously हमें सारे formulas तो याद नहीं रहते, but in the regression kind of these metrics, first like go word by word. We have to compute the error first. Okay, go from like in opposite manner. Error is basically like a y true minus y prediction. That is this value. Okay, uh, let me increase this and let me zoom out. That would be better. Now first thing first, take the last word first. Okay. Uh, error is simply y minus y hat. Okay, then either we have the mean squared error or mean absolute error. Here we have absolute, that means we have to find the absolute value. Then the mean basically we only take when we have like the sum of values divided by number of values, right? So we will sum for each of the sample. Okay, let's take I equals to 0 till m minus 1, or I equals to 1 till m. Okay, that is also okay, fine. Then we will simply divide them with by m, that is the number of samples which we have. So here, like if we see the difference y minus y hat, for the first these values we have the difference as 0.5. For these values we have the difference as minus 0.5. For these values we have difference of 0. For these two values we have difference of 1. Then we simply absolute them. Okay, absolute of, you can say, y minus y hat
Mhm.
means
Actually,
0.5.
it's coming 0.5, but I want to know what is that mean जो ब्रैकेट में है y true y predict.
uh, what does that means? Okay, this two.
मतलब सिंपल मीन एब्सोल्यूट एरर ही निकालना है ना, और कुछ
Mm-hmm.
नहीं है, राइट?
Right, we have to just compute
ठीक
the
है,
simple mean absolute error, then just sum up.
ओके,
You will get 2 and divided by 4 the number of samples, you will get
0.5,
0.5.
ओके,
Yes,
गॉट इट, थैंक
that is the simple thing. इसमें कुछ तो
यू,
ऐसा
ओके,
like there is no other thing. All right, so should we move on to the pyqs now? um
Yeah,
all right,
please.
so I think हमने काफी सारे questions already कर ही लिए from the pyqs.
हाँ, ये भी PYQ ही है, I think.
Yes, okay,
Right.
so
Parampreet, before going, I have a small doubt.
yes.
Uh, in a categorical dataset, if you have so much cardinality, then what to do?
So much cardinality. You can simply use the count vectorizer and multinomial NB. That is for the same thing, right?
Mhm.
Uh, okay. You can simply use the multinomial NB, the same thing which we have here. This one. Okay.
Okay. Okay. Okay.
Okay. First, simply like uh, create the count vectorizer. Create the
If there are so many
frequency.
values in a categorical column, so only single value, but there are so many unique values, then what to do? If we do one hot encoding, then there are so many
All right.
columns.
Yes. Okay. If there are so many unique values, go with ordinal encoding. Okay. If there are
Ordinal.
like a few number of unique values, let's say 5 to 6, something like that, go with one hot
Mhm.
encoding. But if you have, let's say, 100 samples, out of 100 sample you have all 100 different unique values. Okay,
Mhm.
then using one hot encoding is not a good approach, right? You will get 100
Mhm.
columns. Rather,
Yeah,
uh, go with ordinal encoding. The data
but it will
shape will
change the
remain
data
same.
type, right?
Sorry.
But the idea will be gone, right? Ordinal is in a order, but it is not, data is not ordered, so maybe it will
Date.
change the meaning of the data.
um yeah, for that particular column, of course, we can say, of course, that will change the particular that will make the dataset order. But okay, what you can simply do is well, that is okay, इसमें कुछ ज़्यादा मैटर नहीं करेगा. Like at the end, model doesn't consider, right? In mathematics we don't consider like we don't have separate model equations for ordinal or nominal data, right? We have the same equation at the end. So उसमें ज़्यादा
Okay.
फर्क नहीं पड़ेगा. That is mainly for the EDA stuff. Okay.
Okay.
Uh,
Okay.
Also, like you can use a label encoder if you feel so. If you don't want to maintain any kind of order, you can
Mhm.
use the label encoder, or you can
Okay. Thank
randomly
you.
map those values to some integer. or something like that.
Oh, okay.
Okay, basically you
Thank
have
you.
to map them in some manner, right?
Hmm.
So you can go with any of the approach. All of them are fine.
Okay. Thank you.
All right. So the first, okay. Is the font size clear or should I zoom in?
A little bit.
All right. Now it is
Yeah.
fine.
Fine.
Okay. So the first question. Okay. Is this understood? The first question. Um. Okay. Let me.
No, I have doubt in this.
Yeah. Just a second. All right. So the first question. In the first question. All right. We have this. Let's see the first one. We have the array. This is a 2D array, and again we have like in each array we have two elements. So hence we have two different labels. Okay. The first column is the first label. Second column is second label. So this is multi-label indicator. So multi-label indicator or okay, indicator or multi-output you can say. I think there is not much difference. If there is, I don't know exactly. Let me check multi-label, multi-output versus multi-label indicator. I think um, um okay, not getting. All right, so I'll check about it once. Okay. Basically, like this is for the multi-level multi-class classification, the first one. Then the second one, in the second print state, the target, the data which we have.
Excuse me, Param.
Yes.
Yeah, how it is first multi-level indicator or multi?
See, it is multi-label first. First of all, you have to clear with that it is multi-label
Yeah.
because we have two different columns, right? So it is multi-label. Then I think for the if we have the values in numbers, then it will be multi-label indicator. If we have values in in classes, in different classes, or let's say in text like in string values, then it will be multi-level multi-output. I think that is the difference because in mock we have the same question where we have multi-indicator as the answer, right? And here we have the data as in numbers, right? So I think that is the difference because basically numbers are being
But
treated
here
as an indicator.
but
uh,
in mock we have, I think, 0 1
yes,
pair value. Here
yes,
the
so
yeah,
here
this
we
is
have the
pair value.
multi-label indicator, right?
Yeah, here we have 0 1 1 1 the pair value of the, but where we have the single text value.
We
I
don't have the
think that
single text value. See, multi-label, we have the multi-label whenever we have 2D array, you can say, okay, or more than one dimensional target array, then it will be multi-label. Then just based upon the data, if you have numbers, then it will be multi-label indicator. If you have the text, okay, the string values, then it will be multi-output, okay, multi-label multi-output, okay. Then for the second one, 72, 17.89 and 63. So we have like a decimal value with a non-zero decimal value, right? So it will be continuous. Okay. So it is continuous. If we have 17.0, just like 63.0, then this target data would be of multi-class. Okay. Not the multi-label, not the continuous. All right.
Can you repeat that?
Here we have decimal values, non-zero decimal values, 17.889. So hence we have this data is of type continuous, not of multi-class. अगर हमारे पास 17.0 होता, just like similar to the 63.0, then it will be of multi-class, not the continuous kind of data. Okay. Then the last one we have 0 and 1 only, so it is binary only. Okay. So the last one is obviously it's very easy.
From here, excuse me.
Yes.
Continuous mean value continue is coming or coming in continuous like 1, 2, 3, 4. Or it is what is the mean continuous here?
Okay, continuous means when you have decimal values. Okay, just go with that one only. कोई confusion
Oh,
मत create करो. Whenever you have decimal values, non-zero decimal values especially, then that target would be of continuous type. Okay.
oh.
Param, can you put it in a table with an example so that we will get an
All
easy?
right. All right. So first of all, let's go with the multi. Okay, let me zoom in a little bit. So classification for classification and okay, not the classification. I'll write something like that binary classification. Okay, then multi-class classification and then the continuous one. Okay. So for the binary classification you will either have this kind of data, okay, or something like this you can say. Mainly you have only two classes. If you have only two classes, then that will be of binary classification. Okay, if you have multi classification you will have more than two classes like 0, 1, -1, 2, something like that, or 1, 2, 3, 4, 5, something like that. Okay, then for the continuous, okay, one more thing, if we have something like that 0, 0.0, 1.0, that is also binary classification. And if we have 1.0, 2.0, 3.0, something like that, that is also a multi-class classification. But if we have something like that, this 1.0, 2.1, 3.0, because we have a non-zero decimal value, okay, so hence it is like just that this one sample is creating whole data set as in continuous, okay, of continuous type. And another example, anything 8.5, 10.9, or 11.3, something like that. Okay, so this is the difference in
Param, I have a doubt.
yes.
If there are two unique values of same type, then it is binary. If there are three different values, then it is multi-class. I mean,
Mm-hmm.
more than two.
Mm-hmm.
And if they are in decimals and I mean not in the point zero, then it is continuous, right?
Right. Okay, for the multi-class indicator, yeah. Okay, so as per I have seen the data, uh, I figured out this pattern, that is okay, okay, multi-class, right? So multi-class, first of all multi-class, then indicator, okay, versus we have the multi-output, right? So when you have the data something like this, you can say a matrix, okay, like where you have more than one elements, and in numbers, okay, when you have more than one target label, it can be any binary, multi-class, okay, but classification only, not the continuous one. 0, 2, 0, 1, something like that, like this. When you have the numbers in like in various target labels, then it will be multi-class indicator. When you have text values, something like this cat and male, then dog, again male, let's say now cat and female, okay. If you have the text data, then it will be multi-class multi-output. If you have numbers data, the data in numbers, you then it will be multi-class indicator. Jitna I have seen the data, as per that, like I found out this pattern, okay. All right, so this is it. Now this one, ये question तो हमने किया ही था अभी mock में. Then again this question is same. Okay. Then this question. All right. So we have our data set something like this.
Actually, in previous question, there are three like F1 recall, and then we need to choose in the previous one question the recall value, F1 value.
Previous question F1 and recall value, what do you mean?
I mean here the option is same as like the mock, but we choose only F1, I think, in this.
Okay, this one. Okay, here we have MCQ, right? As I told you, if we have MCQ, then choose the F1. If you have anything like that, if you have MSQ, then choose all of the suitable options, right? So okay, we are discussing 2024, the latest PYQ. Okay, the previous term quiz 2 question paper. Okay, then we have this question. We have two SGD SGD regressor. We have different penalty values, and these are the respective coefficient values. Okay, so which, like, out of the two, like lasso and ridge regularization, which one are L1 or L2?
Here,
Not here, generally.
Generally, for
okay, lasso is L1.
yeah,
ridge is L2, lasso is L1, ridge is L2, and ridge, I think ridge tends to 0, right? Ridge tends the weights to 0, if I am not wrong. Let me check. Okay, sorry, lasso tends, sorry. That is a little bit confusion. So lasso is L1, ridge is L2, and wherever we have the weights as 0, exact 0 values, just like आपको clear हो जाएगा that is the lasso, means that is the L1. So for the SGD2 we are getting 0 weights, some of the values are 0 weights. So L1 is the second one penalty here for the second model, and L2 for here. Okay, so this is just a simple, you just need to know the intuition behind both of them. Okay, then the mean absolute error, the same question hai.
Is there any other difference we find in the previous question? We have to only find 0, or
we have to only find 0. Okay, ridge never makes the weight 0. Okay, but lasso makes the weights 0 because of the equation which we have. Like in lasso we have the okay, in lasso we have the absolute term, so it tends to make the weight 0, like it tends to minimize the values of weights, like whichever does not which do not have the importance in training the model. Okay, so then we have a question. Yes, Santosh.
Yeah, continue.
Okay, model ML pipeline to pre-process the data, and we are using SVM. Okay, so this is the data and all. Then pipeline dot predict. Okay, so they are asking what is the purpose of pipeline. I think ये तो बहुत clear है सबको. Pipeline doesn't combine multiple models. Pipeline allow for simultaneous, this is not. Column transformer allows for multiple. Okay, not in fact the training. Column transformer is for transforming the data set. And then the pipeline simplifies the code by encapsulating pre-processing and modeling steps. That is right. Pipeline ensures that only so obviously the third option is correct. That is a definition for pipeline. Then given the below code, okay, so we have a parameter in all the reading, you can say reading functions of the pandas, that is chunk size. Okay, if we have a very big data set, we can read chunk by chunk, like some portion of data. Okay, so 1024 means 1024 bytes of the data we will read. Okay, like that. So we will read that data, that much data in one chunk, and then we will get another chunk in the next one. So it's kind of a, you can say, we get a iterator, and for that iterator we can iterate on it via for loop or any kind of, or a while loop also, and then we can extract the x and y and do other things. Okay, chunk size is the basic parameter. Then the count vectorizer. Okay, count vectorizer simply. Okay, so Amit, you were asking the question like that. So we have multiple sentences, right? We have two sentences, and count vectorizer first make the text lowercase. So okay, so we it is printing feature names. Feature names here means all the
Varun,
yes.
we have a lot of confusion between count vectorizer, hashing vectorizer, and this TF-ID vectorizer.
Okay, which
Can you
one?
just
In which one you have the confusion?
count vectorizer,
Mm-hmm.
hash, hashing vectorizer, and TF-ID, right? We have only seen only three vectorizer, right?
Yes. See, I have not worked much with the text data, so मुझे ज़्यादा कुछ clear नहीं है, confirm नहीं है. So, but I just know this. Count vectorizer simply gives you the words frequency. Okay. Uh, then the TF-ID, that one simply, I think that is for the, that gives you the one hot encoding kind of data. मुझे अब ज़्यादा मैंने कभी उस पर वर्क नहीं किया, सो मुझे ज़्यादा आइडिया भी नहीं है, सो I can't tell. And the hash one is like the, as the name suggests, it is like it is finding the hash value of each value, uh, hash value of each word, and based on that it do the mapping some kind of like that. But मुझे ज़्यादा clear नहीं है, so मैं ऐसे कुछ भी नहीं बताना चाहता. Okay.
Okay. How can we understand this count vectorism in C?
You can use chat GPT में clear हो जाएगा in fact. Okay.
Okay. Okay. Okay. Okay.
Okay.
Thank
So, okay, we are printing the feature names. Okay, so here in the count vectorizer, feature names are the words, the actual words which are used for the mapping. Okay, basically you can see the keys for this dictionary. Okay, and in the sorted manner here we have. So get feature names out gives us the feature, the words which we use for the mapping, and in the sorted manner. Okay. सो बहुत ही सिंपल था. इनफैक्ट सी गाइस, मैंने भी बहुत सारे चीज़ों पे वर्क नहीं किया है. सम थिंग्स आर रियली न्यू टू मी, लाइक द नेव बायस एल्गोरिथम एंड ऑल, बट आई एम जस्ट लर्निंग साइड बाय साइड whenever I am encountering this, like the count vectorizer. मुझे ये अभी पता चला, like it sorts the data, it lower case the data first, then it sort the data. I literally, मुझे कोई आइडिया नहीं था इसका. So that is just, we have to simply look into some examples in the definition and आपको clear हो जाएगा. Okay. Then we have, imagine you are training a perceptron, and given the linearly separable nature of the data, how many iterations you would like take for the perceptron to convert. Okay. Iterations equals to 1. We cannot like set any kind of a specific value for the iterations. Okay. चाहे हमारे पास कोई भी मॉडल हो, बिकॉज वेट्स जो है रैंडमली डिफाइन होते हैं. इफ़ वी हैव, if we are passing some specific value of weights, some custom value, then we can find the number of iterations obviously. But then also we are not sure, क्योंकि derivatives में भी थोड़ा सा होता है, so we won't go into that stuff. So we will simply eliminate the numbers option. Then the last option is iterations value can vary since the data is being shuffled in each epoch. Yes, so we have shuffle equals to true, which means हर बारी जो है data shuffle हो रहा है, like after each iteration. So number of iterations may vary according to the data which we have. So that is the correct explanation. Then we have these things. Okay, scalar with mean true and false, assuming that xn and xy are given. Which of the following statements is correct. Okay. Standard scaler will scale both x and train before training a classifier. Both, no, standard scaler will only train the x train, right? It doesn't scale the y train, the y labels, right? So it is not correct, and all the classifiers will not be trained on scaled data with zero mean and unit variance. That is correct. Can anybody tell me why that is correct? Simply definition code में ही है. Okay. See this one. Okay. Okay, थोड़ा नीचे हो गया. Where, okay, where we were exactly. Okay, काफी ऊपर नीचे हो गया. Yeah, that is fine. So we have scalar with mean, right? With mean parameter, with mean true and false. So कुछ मॉडल्स बनेंगे where we have the value, the data is transformed with the mean, okay, and कुछ ऐसे मॉडल्स भी बनेंगे where the mean and the variance will not be counted because we have the value false as well here, okay. So that's why this option is correct. All the classifiers will not be trained on the scale data with zero mean and unit variance because we have true and false, two different values here. Then the pipeline always uses a radial basis function, which is RPF. No, it pipeline uses two different kernels, linear or RBF, not always RBF. So that is clear. A total of 18 combination that we can check by multiplying the number of. So we have 3 here, 3 here. So 9. Then 2 here. That is 18, and 2 here. So 36. So we will have 36 different combinations or 36 different models for the grid search CV, this one, okay.
How 36 from?
Okay, simply take the unique values in each of the lists, okay, multiply with the different unique values of each of the parameters, okay. So हमारे पास यहाँ पे 2 है, यहाँ पे we have 3.
Right.
So we will, for
Yes.
each value of true, model will train on these 3 values. Similarly, for
Yeah.
this value, model will train on this value, this value, this value, and hence other values as well. So 2 into 3, 6, then into 2, that is 12,
36.
and then 36. Okay, 12 into 3, 36. So just simple maths. Then next question, logistic regression, class weight balance. Okay. Yes, in logistic regression, C basically indicates that model will imply regularization. ये आप documentation से देख सकते हो. And I really don't know why IITM is like trying to do this thing कि एक parameter का, okay. But that is something we have to do. Yes.
What is in the question? I didn't understand.
So. Mm-hmm.
Like you have said something about item.
Sorry, which one? Can you repeat?
This one only.
Mm-hmm.
What is happening in this question?
Okay, so we are having a logistic regression model and class weight is balanced. So both of the classes will be considered as a same class, means the proportion is same, okay. Like in generally logistic regression works for binary classification. We can also set it for multi-class as well. Then C parameter, C is for the regularization, like how much regularization should we have to add in the model, okay. It ranges from 0 to 1, similarly as the alpha parameter which we have in SGD regressor or classifier, as well as in linear regression, okay. So it is similar to the alpha parameter, nothing different, just that the name is different. Then which of the following is true for a hard margin SVM? It is robust to outliers. It will correctly classify all the data points if the data is linearly separable. Okay, fourth option is incorrect. It is mostly for clustering the data. No, as hard margin, or in fact SVM is not only for that. SVM is for classification. Okay. Then it is robust to classifiers. Soft margin is, you can say, uh, like it tends for okay, not the hard margin, but मुझे exact definition नहीं पता, so I can't say like that.
I guess soft margin does not separate or like outliers.
Okay,
It does not separate outliers.
okay, okay, so we will consider that. Then we will have like this correct option. Okay, so let's move forward. Radius neighbors classifier, that is something new. ये तो हमने कहीं नहीं पढ़ा ना. I think that is not in
Uh,
the
it is
slides.
in, I guess, week 9. It is in.
It is in week 9 ना. Okay, so forget that. क्योंकि ये मैंने कहीं भी एक्टिविटी क्वेश्चन में भी नहीं देखा, रेडियस नेबर क्लासिफायर.
Sorry. It is with the k neighbors, where the k neighbors is taught.
Okay,
This was there.
okay, all right. So radius neighbor classifier, as the name suggests, it kind of like takes a neighbors from a particular radius, I think. Okay, so only n neighbors in the range of some, no, n neighbors basically means like the number of, you can say, centroids, or kind of how many decision boundaries you want. Okay, all the neighbors in the range of some radius are used to compute the label of a sample. Okay, that would be correct. And the feature scaling helps in improving the score of, okay, that I don't know. Feature scaling, how it helps for this radius neighbor classifier, but generally feature scaling does not help for the KNN mainly. Okay.
Mm, I
Then
guess it scales in a way that some point lie in particular radius.
okay, that you can say, uh, like, but we have seen here um, some like this. Here on the left hand side we have the same dataset, on right hand side we have the same, but right hand side is of scaled dataset. So I think KNN works in the same way, right? Like, right. But I don't know about this, the radius neighbor classifier exactly. Okay. Um.
K neighbors depend upon the value of k. Okay,
Yes.
and in radius neighbors, it depends on upon the samples which come under some particular radius.
Okay. Okay. So if we are scaling the data set, then वो radius में more number of samples will be included, right? We can say on that particular
Yeah.
radius, right? Okay. Then SGD classifier, which of the following is correct? Perceptron is a loss function, you can loss parameter. Then okay. Then we have percept is not any kind of, and like documentation we can see sigmoid is not there. We have the log loss. Okay, so we have log loss, hinge loss, squared loss, perceptron, and um, 2 3 other as well, I think. ये पूरा it is of the documentation only, so we
So
have
do we
to
have to remember the parameters?
sadly yes, that is like, it is not the correct approach, but it is what it is. Okay. uh, which of the following is correct for precision recall? Okay. A high area under the curve represents both a high end recall and high precision. Yes, something like that. If I show you the precision recall curve.
How many PYQs are we going to cover?
Let's see, I think 20 to 25 minutes more. जितने भी हम कर पाएंगे we will cover that.
So in the end, please can you re-explain the topic of confusion matrix?
Okay, I have already explained it like
I
once.
missed that.
You can watch my earlier session, like my session number 15. I have explained the confusion matrix in very detailed manner in the session 15, like using I think 3 to 4 examples in the session 15. This one, logistic regression and evaluation matrix. You can watch my this session. I have explained it there.
Okay, I will re-watch this session. Request you to upload this soon.
Yes, I will upload this like around, I think, 2 p.m. because it will take some time to pre-process, right? The video recording.
Okay.
Um, okay, where were we? Yeah.
Varun,
Yes.
have you listed the type of NAT type of questions we can expect?
Sorry.
Uh, NAT type of questions we can expect
Not
in
till
this.
now. I haven't found any NAT questions.
Okay. In the mock, how many NAT questions are there
I think zero.
basically?
Uh,
No,
yeah,
no.
zero. There are no NAT questions.
At least they will ask us to calculate mean square error
Yes,
or
that you can consider as a NAT. Okay. They will provide some range of answers, like for the precision and for the mean absolute error. But they have asked in MCQ here.
anything else they can ask for NAT type of questions.
Not like
Guess.
um, this can be considered as a NAT, like um, not any other, I think.
Okay.
Yes, not any other. That much is fine. Okay. Then the precision recall curve shows the trade-off between. Yes, that is correct. Used to evaluate unsupervised. No. This option is not correct. None of this. No. This option is correct. It is the definition for
I,
precision recall curves. Right.
I think there was some different question.
Okay. Yes, I think so. Okay, थोड़ा सा change होगा. I don't know how. Okay, so we have covered this one. We have covered this one. We have covered this one. Okay, this was the question, right? Uh,
Yes, yes.
a higher area under the curve represents both higher and high recall and high precision. The precision recall curve shows the. Okay, so this is the correct and this is incorrect. Yeah, this was the option. A higher area under the curve represents. Okay, so here we get something kind of AUC curve, you can say. We use your ROC curve. We have different kind of curves. Not AU, sorry, not AUC, ROC curves mainly. What are like ROC curves? If I go, I well, by looking at the mock and the PYQs, I think only 5 to 10% of the questions will be of NAT. Okay, so that we can consider. Okay, so true positive rate and false positive rate. We have plotted here. Okay, that is different. A higher area under the curve represents both high and high recall and high precision. We don't have any example. मेरे पास एक visual example होता. I have seen one like okay, abhi I don't have. But mainly like it is saying like uh whenever we have high recall and high precision, uh that is basically okay. The high area under the curve represents both high recall and high precision. Um, up, how can I define it? Like we can simply create a example diagram like this. Like here we have the precision, here we have the recall, and 0 to 1, like, okay, what just happened? So 0 to 1, it will go something like this. So here we have the higher values for the precision and recall. So this is generally how precision and recall curve looks like. Okay, um like from here 0 to 1, and same for the recall value. So the higher the curve, the higher values for the precision and recall would be. So I think like that, but I don't have a like एक मेरे पास एक curve का था diagram. I will share it in the group if I find it. Okay. um for these visualizations, like for the AUC curve and all, mainly we will cover that in week 9, because week 9 में they have covered all these parameters in detail, but we have already covered it, so I'll cover three metrics: the AUC, ROC curve and AUC and all. Okay. Then which of the following statements are true? So k near with low values of k produce complex decision boundaries. That is correct. Scale of the features can impact the decision boundaries. Yes, scale of the features can impact. Okay. Columns. Scale of the features can impact the decision boundaries. Scale, I think that is the like same thing for the similar. It is like similar to the radius neighbor classifier. If
Yeah,
that
also
so.
the same the for radius.
Yes.
And here from here the n underscore neighbors. What is this?
N
Value of
underscore neighbors represent the value of k. Okay.
okay.
Yes, Shankar.
Yeah, but instead in C option,
Mm-hmm.
if the question will like keep uh, scaling करने से it will affect the decision boundaries, so answer will be false, right?
Yes, of course.
Okay, okay.
Okay, so then we have C equals to 8. A multimonial. Multimonial means we have more than two classes to predict. Max iter 100.
Sorry, no. Just would like to go back to the previous question. So if the answer is false, then here it is given as true. So a little bit of confusion there.
I think it should be false because like scaling does not affect the decision
Yes.
boundaries, right?
Yeah, that's what we discussed earlier. Yeah.
Right. Because even if we scale the dataset, decision boundaries will remain same.
So in this case, if it is multiple choice, then it should be what only the
It
first
is
one.
multi-sect. Maybe incorrect mark ho. We don't know the exact, like there are
Yeah.
many questions in the PYQs which are marked incorrect. Okay. So logistic regression with this regularization and other things. So logistic regression is made up. No, it is not for binary classification because we have multi-classes, multimonial. Then model does not know because C, we have set C to some value 0.8. Then model has been specifically set up to handle a multi-class classification using a softmax regression. Okay, you don't need to go into softmax one. Okay. Softmax regression is like you can say an advanced version of sigmoid function. Okay. it it is like for finding the probabilities for multi-class classification problem. uh, Regarding the formula and all, I will show you in the next session. Okay. Just that is key, you can simply mark this option based upon this, that the model has been specifically set up to handle a multi-class problem. Obviously, if we set like multimonial as a multi-class parameter in logistic regression, it will use the softmax regression approach. Like softmax is same as a sigmoid, but is a like upgraded version, you can say. Okay. Don't need to go into the formula and all because softmax थोड़ा सा आ जाता है in the neural network stuff, like it is one of the activation functions. Similarly, sigmoid is also an activation function, but that is a different thing. But if feature one is scaled and another is from scaling, the features will affect in KNN. If one feature is scaled from 0 to 1, another is from 1 to 1000. That will also not affect the data, like uh okay, if I simply take this one, and if I simply plot it here, and if I simply select these values, and okay, I'll okay, if I simply scale it something like this, right? You are asking one feature is scaled 0 to 1 and another is scaled 1 to 1000, something like this. Okay, गायब हो गया. Like this. So again, like decision boundaries will be made something like that, but okay, yes, it can impact. If we see the like if we try to plot some decision boundaries, it will impact the data somehow. Like here we can see, okay, these two are colliding, right? Not colliding in fact, but they are very close compared to the above one, if we see. So
But Parampreet,
थोड़े
if you just
confusion है.
draw the decision boundary, after that, if you do a scaling,
हम्म.
okay,
हाँ.
then the boundary is also just going to scale down, scale up along with it.
Yes, इसलिए थोड़ी मुझे confusion हो रही है. I have the same doubt in my mind. थोड़ी like I have this confusion. um okay, I just scaling will impact okay, and like how it will impact, uh, so scaling impact the decision boundary in the data is which will dominate the distance. Okay, okay, regarding the distance, the calculation of the distances, okay, so that will impact. It is written, but um so here we have this, okay, that is not okay. So this is some kind of an image which we have. So the left one is like KNN without scaling. So we will have these linear decision boundaries, you can say. Okay. The right one is with scaling. So we have a clear decision boundary for like we can clearly classify the data, right? So yes, this is one of the example which basically states that condition true, that KN that scaling the features impact the decision boundary. Okay, I didn't know before. मुझे कोई आइडिया नहीं था इसका कि ऐसे होगा, but yes, we got one example. So that option is correct. Like we can use this example for that option. All right. So different things. Okay. The model might iterate through the data points multiple times with limit set to 1000. So simple उसकी definition है. Find the missing value. So poly can be there. Okay. Kernel. These two are not the kernels are either linear, poly, RPF. Okay, we have the sigmoid as well. Okay, so sigmoid is also there. So again, we can look into the documentation for the kernel parameters. Then this one, if the shape of how many columns will be there in this. Okay, include bias and all. So we have 4 features as of now in the X. Then degree equals to 2. Means हर एक तो we will get the square as well. So okay, we're getting PDF में we have the different, I don't know how. Okay, questions are repeated, right? This question is repeated again, something weird. Okay, let's move on to the another one. Okay, do you guys want to discuss any specific question or like any specific PYQ? क्योंकि we have a lot of PYQs and ऐसे तो बहुत time लग जाएगा.
Was it of the previous term?
Yes, it was of the previous term. the term 1 of this year. And this is of 2023 September term. Do you guys have any specific question to discuss? Like anything for any PYQ? Okay. So I think like ऐसे तो we will have बहुत ज़्यादा टाइम लग जाएगा. It's better कि अगर कोई specific question है that we can discuss, so that will be better. Okay. Then it's just like leave it. It's better like अगर हम खुद देख लें, because ऐसे बहुत सारे PYQs हैं उसमें तो काफ़ी टाइम लग जाएगा and इतना टाइम तो है भी नहीं. So that is it then. Do you guys have any specific doubt in anything? Okay, if not, so let's end the session, guys. So that's it. And